Hey guys, Miss Milson here. Today we're going to look at relations and functions notes. At the end of this video, you should be able to represent relations in a variety of ways. You should be able to identify the domain and range of a relation, and you should be able to differentiate between a relation and a function. Okay. A relation is a set of ordered pairs. Okay. That's really it. Any group of x and y coordinates works as a relation. Okay, and relations can be listed in a variety of ways. They can be listed list of ordered pairs. They could be a graph. They could be a table. Sorry, guys. And they can be used as or shown as a mapping diagram. Okay. The domain is the input of relation, x values. Okay, and the range is the output, or y values. Okay, so when you're done, or when you're really into this chapter, domain, input, x values, and range, output, y values, they'll all be interchangeable words that you'll know. This means that, means this. Okay, so as we list these, example, we are given this list of ordered pairs. They ask us to write the domain. When we list out the domain, here are our rules. We will make sure that we list the x values with no repeating values. Okay, and I always like to go from least to greatest just so I can make sure that I'm checking everything off the list. -3, 2, 4, 6. Least to greatest, no repeating values. Here is my domain. My range does not have to be like in the same order that, hey, I put -3 first and I put 4 first. I just list the y values from least to greatest without repeating. So -1, that happens twice. 4, 7. Again, notice I did not have to write -1 twice for my range. Again, domain, x values, range, y values. All right, when a domain or range value is repeated, we only need to list that repeated value one time. Okay, number 2, now we see that this information in a table doesn't really change how we approach it. We list the domain, the x values, 1, 2, and there's 3 written twice, but again, I'm only going to write in my listed domain values one time. My range, I've got 70, 84, 92, and 99. Okay, and you'll see different places write these different ways, out of order, maybe writing it from the top to the bottom or left to right, however they're listed. Again, I list mine from least to greatest because it gives me a way to check that I've done everything. And when I go back and check it, I can have a process or a system so I know what's happening. All right. Number 3, here we're given a graph. Okay, and they're asking us to write the domain and range. Okay, again, that still means the x values and the y values. So start this problem out. Let's do this right a little bit smaller. So I have this value of -3, 2. Have this value of -2, 1. 0, -1. 3, 0. And 3, 2. Okay, so now I have these values. All right. So listing my domain and range. So my domain is my x values. -3, -2, 0, 3. For my range, listing my y values. I got 2, 1, 0, -1. 2, 1, 0, -1. All right, there we go. All right, make sure I didn't repeat anything. We're good. Okay. So that was all relations, and any set of ordered pairs is a relation. Now, we're going to start talking about functions, okay? And a function is a relation that assigns exactly one value in the range to each value in the domain. In other words, a function is a relation in which the x value does not repeat. Okay, it's one function where the input, I said x value, I really like input better. I'll say both of them. The input does not repeat. It does not give you a different output. Okay. Vertical line test. Actually, let me build on that here. All right. No, I'll do that in class. It'll be good. All right, vertical line test. Vertical line test, it says a test used to determine if a relation is a function. If any vertical line passes through more than one point in the relation is not a function. Okay, we actually noticed that hopefully here. You might have seen that and like, what's this blue line for? Okay, as we looked at this graph, sorry guys, screen's being really sensitive. As we looked at this graph, you notice this vertical line here, this blue vertical line that goes through the point 3, 2, and 3, 0. If we were to use a vertical line test, and see how good I am at this, can't find it. Okay, if we were going to use a vertical line test here, we'd have a vertical line here, only goes through one point, only goes through one point, only goes through one point. And then here, this vertical line goes through 2 points at the same time. Okay, this relation does not pass the vertical line test, so it's not a function. Okay, because that means that 3 has the output of 2 and 3 has the output of 0. All right. So it says tell whether or not each of these relations represents a function. Explain why. Okay, and so this is exactly it. I should have known. Okay, this is the same graph. Notice that this vertical line passes through both points. Okay, and so here, these 2 points here. So tell whether the relation is a function. No, does not pass vertical line test. Here we have a circle, and we can see multiple times where the vertical line intersects our graph twice. So this is not a function. No, DNP as the kids say. Just playing, does not pass the vertical line test. Okay, and here we have a parabola, and you'll see that there's really close, like everything looks really close, but there's no time where there's something stacked on top of each other. So even though it seems really continuous, this is a function. Yes. Again, it passes, not again, but it passes the vertical line test. All right, number 4. Asks again, is this a function? So here's how we can tell. We're going to say, what are our x values? Do our x values repeat? Okay, and our inputs and outputs. So we have 4, 9, -2, -2, 0, 4, and -2, 5. So here is where our red flags come up. We have -2 twice. Our input is -2. What will our output be? Well, here it says our output is going to be -2. Here it says our output is going to be 5. Okay, so each x value should only have one y value associated with it. So this is not the x values -2 gives different y values. Okay. So I am going to give you this illustration off to the side in just a second. All right, let's make a vending machine. Do. All right, a different word for function is work. Okay, when I was a kid, vending machines were everywhere. When I was a student, it was actually a huge problem. Everybody was trying to put healthy foods in vending machines because they thought that having healthy options would help kids stay healthy. But it actually just made people not use vending machines. So then companies would put apples here and then Skittles here in the middle row. Okay. And most of the time, what happened was like the apples stayed there forever because nobody wanted the apples. They wanted the Skittles. Okay. And so if you got some extra spending money, that's what you bought, the Skittles. Okay. So let's imagine that you're trying to buy these Skittles, right? And these Skittles are here. They're in blue. You want the Skittles and not the apples that are up top. Okay. So to get the Skittles, you had to press the button. Like, I don't know, I'll make this button 2. And to get the apple, you press the button 1. Okay. So here's how this relates to a function. If I press the button 2, I want the output to be 2. So if my input's 2, I want my output to be Skittles. Okay. And so if I go to this vending machine and I hit 2 and I get the output Skittles, then I say, okay, this vending machine works. If I went to the vending machine and sometimes when I hit 2, I got Skittles, and sometimes when I hit 2, I got an apple, I would say this vending machine does not function. See, I did that. Doesn't work. Okay, so this vending machine doesn't work because the input gives me 2 different outputs. Sometimes I get Skittles, sometimes I get apples. Okay, and so this is why, as we look at this function, or this list, not function, because it's not a function, this list, this says sometimes when you enter -2 comes out. Sometimes when you enter -2, 5 comes out. This is not a vending machine that I want to go to. I need to have some predictability. All right, so now let's look at this next example. Next example says, our x value is -1, output 6. X value is 3, output 6. X value is 6, output 6. X value is 7, output 6. Is this a function? Now people tend to say, like, no, it's not a function because everything gives you 6. Okay, again, let's look at the vending machine idea. When I got my first gym membership at LA Fitness, I went in there and they had a vending machine, and I thought this vending machine was so weird because it had so many slots. Nope. And all the slots, let me do this thing, there we go. And all the slots were the same chocolate protein drink. It's like 12 options for the same chocolate protein drink. Okay, and so no matter what you pressed, what you get out is a chocolate protein drink. So if I put -1 in, I get a chocolate protein. 3, chocolate protein. 6, chocolate protein. 7, chocolate protein. Did this vending machine work? Yes, because what I put in, I knew what I was going to get out. Okay, again, the input is the important part. If I input something, do I know what's coming out? In this case, yes, I do. Okay, so that's the difference. Okay, we'll look at that later if we need to, but usually that's the illustration that helps to identify what a function is and what a function is not. Okay, here we go, mapping diagrams. These are fun. It says create a mapping diagram for each relation, then tell whether each is a function. For number 1, we have 2, 3, or 2, -3, 2, 0, 2, 5, and 2, 12. Okay, so as we look at the mapping diagrams, our first circle is the domain. You don't have to label this domain because it's going to be the domain. And our second circle is the range. We do our domain circle just like we list our domains. The x values, least to greatest, no repeats. So all my x values, well, they're all 2. My range, the same way we do our range when we do our list. Least to greatest, no repeats, -3, 0, 5, 12. And then all we do is we connect these values with arrow. So 2, -3, that's our coordinate. 2, 0, coordinate. 2, 5, coordinate. 2, 12, coordinate. Here's what we're looking for. This is what will tell us whether the function is whether the relation is a function or not. When we look at our x values, and we'll say, is there more than one line coming from each x value? The answer is yes to that. It's not a function. Is this a function? No. Again, sometimes when I input 2, My output's -3. Sometimes when I input 2, it's 12. I don't know what my output will be. It's a vending machine I would not want to go to. I wouldn't want to spend my last dollar and not know if I'm going to get 0 or 5. So no, it's not a function. Number 2, doing that same thing, I'm going to go least to greatest, -1, 0, 2, 7. Here I'll go -4. What is it, 3, 8? All right, so now I'm going to connect those with my line. So -1, 3, 0, 8, 2, 8, 7, -4. Is this a function? Well, ask yourself, when I input, do I know what I'm getting out? And so as we look, each x only has one line coming from it. So the answer is yes, I know what I'm getting out of it. Okay, so it is a function. Okay, again, you can put in 0 and get 8. You can put in 2 and get 8 because you know what you're going to input to get the output of 8. This doesn't work because I don't know whether I'm going to get -3 or 5 when I input it. Here, if I put in 2, I'm going to get 8. If I put in 0, I'm going to get 8. If I put in -1, I'm going to get 3. If I put in 7, I'm going to get -4. There's no two ways about it. All right, so there you have it. Looking at listing domains and range, or listing, domains and range, and identifying and differentiating between relations and functions. See ya.